Okay, so every single one of my algebras I taught a little bit differently. We'll see how well things land. Um, I mentioned before, like I could teach you this whole unit in probably an hour. It's there's not a whole lot to it. Quite honestly, you need this formula, which can be shown in two various ways. So whenever you think of an exponential function, you need to be thinking of y equals a times b to the t power. Or you might want to also remember this one because sometimes what you're multiplying by each time is unclear. All right, but we know something is exponential if for every value in the y, as it's like increasing by 1 in the x, if you are multiplying to get the next number. Okay, so let me go to the notes real quick because I only really showed my first hour this part of the notes. So we'll point this out. Think to yourself, don't say it out loud, but think which one of these is exponential. Just thinking. Which of them is growing with an exponential? Right, raise your hand if you think table A is the exponential function. Raise your hand if you think table B is. Okay, it is. Maybe it's not clear what it is multiplying by each time. I could show you how to figure out what it's multiplying by each time. But clearly, table A is what type of function? A linear function. Because why? Okay, good. And when we say go up by, in this one, we mean like it's adding the same amount each time. That's really like specific, adding. Because things could also increase in exponential functions too. But in table A, as x is increasing by 1, which is only important to note so that way you know like there shouldn't be any change in the pattern over here. The y's are increasing by how much? Stay with me, pay attention. The y's are increasing by how much each time? It's adding 1.5 each time. Don't believe me, use the calculator. Like, yeah, 5 plus 1.5 is 6.5. 6.5 plus 1.5 is 8. That's why it's linear. For exponential, again, it's important to note, like when the x is increasing by 1 each time, it should be easier to see the pattern. But what it's multiplying by each time might be unclear. Here's how to figure it out. Just like how if I was trying to figure out what it's adding each time, I might do the opposite of adding. I might subtract. I might take like 3.5 minus 2 to get 1.5 and see if it's consistent throughout. What's the opposite of multiplying? Dividing. Dividing. Opposite of multiplying is dividing. So if I take a number and divide it by its previous number, that should give me what I'm multiplying by to get the next number. And here's how. I mean, you could use a calculator. 2 times 3 halves. What's 3 times 2? 2 times 1? What is 6 divided by 2? And isn't that my next number? See if it's consistent throughout. No. So now do 3 times 3 halves. What's 3 times 3? 9, pay attention. 9 halves is my next number. That's the pattern. I'm multiplying by 3 halves each time. I know fractions, people see them and they just tend to kind of like take the L on those problems. There will be lots of fractions on our test. So like you can't just like say, oh, I'm just going to get that one wrong, it's fine. If you want to know like what 9 halves times, let's see, 3 halves is, you can use your calculator. What I would recommend is any fractions that you're putting in a calculator, put them in parentheses like how I'm doing, so the calculator reads it right. And if you want your answer to be a fraction as well, press this little button. Pretty much all scientific calculators have this button, or fraction to decimal button, that will give you the equivalent fraction. Okay, so that's how you know what it's multiplying by if it's unclear. Take a number, divide it by its previous number, see if that's what multiplies. Okay, so anyway, that's our exponential functions. They multiply each time to get to the next number. Let's see. So exponential can be represented one of two ways. It can be a times b to the t power, or this one that I taught you guys, I didn't necessarily teach my algebra students until today. This other one that works if we have like percents or something that it's like increasing or decreasing by. So let's see. What does A stand for in each situation? Initial amount. What does B stand for? Common factor, right? It doesn't start with a B, but like just kind of understand that they're solving B, our common factor. It's what we're multiplying by each time to get our next number. So like the 3 halves in that table we were just looking at would be our common factor. And what does T stand for? Time. Sometimes you see an X there, X is usually time anyway, right? Now the difference with this one is instead of putting B, they have it as 1 plus or minus R. R being the rate that it's either increasing or decreasing by. And if it gives you a percent, make sure you're plugging it in as a decimal note. Like that's important. So let's do an example, like a random one. I need you to participate. Say that I want to buy a new purse for $550. And it's Black Friday, so there's a sale. Hold on. I said, hold on. Oh. You can just like apply pressure. Just apply pressure until we're done. All right, anywho. So buy a new purse, $550. It's Black Friday though, so it's 15% off. Plus we have sales tax. Our sales tax is 8.5%. In the lesson, like you could get the answer by figuring out what 15% of 550 is and then subtracting it from the original. But honestly, that's a lot of steps. We learned in the lesson that what you could do is set it up something like this. So my purse is $550. If I want 15% off, would that add or subtract from the price? It would subtract. So I would do 1 minus the rate as a decimal. So what's 15% as a decimal? $0.15. To the T power, I'm only applying that discount once, so my T is going to be 1. All right. What is 1 minus 0.15? Like $1 minus 15 cents is how many cents? 0. So if I multiply by what it's keeping rather than what's like taking away, I will get my price with the discount already. Like instead of doing 550 times 0.15 and then subtracting it, I could just get it in one step by doing 550 times 0.85. And that'll give me that its sale price is $467.50. All right, if for some reason we had to apply that discount multiple times, that's where the exponent would, right? But we're not necessarily doing that in this situation. If I then needed to add my sales tax to figure out how much it's gonna actually cost me total, I would times it by 1 plus, because does tax add or subtract from the cost? Guys, say something. Does tax add or subtract from the total cost? It adds. Tax is an additional fee. Not sure if you guys ever buy anything, but like it is. If the tax rate is 8.5%, what is that as a decimal? 8.5% as a decimal. So any percent you can make a decimal by dividing by 100%. What's the equivalent decimal? No, that would be 85%. Okay, that is 8.5% as a decimal. And we would only apply it one time, so my exponent would only be 1 in this situation. So then when I do 467.50 times 1.085, so that's me adding it together, the 1 and the 0.085, my purse is now costing around $507. $507.24 to be exact. But yeah. All right, so yeah. Attempt to practice. You have still 20 minutes to work on it. The practice we are talking about is 5.04. That's your main priority, even if you've been absent the past few days. That practice. And then you can go back and work on the others that you did. Since you're all here today, I'm going to hold you to 80% or higher in the 5.04 practice. You can go wash your hands now. All right, questions? Yeah. When Gavin comes back.